I'm Mrita from Institute of Aeronautical Engineering, Department of Electronics and Communication Engineering. My Tech Talk topic for machine learning techniques and practices is comparison of supervised, unsupervised, and reinforcement learning with use case mapping. Introduction to machine learning. Machine learning enables computers to learn from data. It is broadly categorized into supervised, unsupervised, and reinforcement learning. Each paradigm has unique characteristics suited to different problems. So, here machine learning is divided into three types of learning. First one is the unsupervised, second is supervised, and third one is the reinforcement learning. What is supervised learning? Supervised learning uses labeled datasets to train models. It predicts outcomes based on the input's features. Commonly used for classification and regression tasks. So here we can see the three types of learning. So coming to the criteria definition. Supervised learning. The machine learns by using labeled data. Unsupervised learning. The machine is trained on unlabeled data without any guidance. Reinforcement learning. An agent interacts with its environment by performing actions and learning from errors or rewards. Coming to the types of problems, supervised learning, regression and classification. In unsupervised learning, association and clustering. In reinforcement learning, reward based. Coming to the type of data, in supervised learning, it's labeled data. In unsupervised learning, it's unlabeled data. In reinforcement learning, it's no predefined data. Coming to the training, in supervised learning, external supervision. And coming to the unsupervised learning, there is no supervision. And coming to the reinforcement learning, there is no supervision. Approach in supervised learning maps the labeled inputs to the known outputs. In unsupervised learning, it understands patterns and discovers the output. In reinforcement learning, it follows the trial and error method. Use cases of supervised learning. Email spam detection classifies emails as spam or not. House price prediction estimates real estate values. Fraud detection in banking identifies suspicious transactions. Strengths of supervised learning. High accuracy with quality labeled data. Clear evaluation metrics like accuracy and precision. Suitable for problems with well-defined outputs. Coming to the limitations of supervised learning. Requires large amount of labeled data. Overfitting can occur with complex models. Not effective for discovering hidden patterns without labels. What is unsupervised learning? Unsupervised learning finds patterns in unlabeled data. It groups or reduces data dimensions based on similarities. Often used for clustering, association, and dimensional reduction. Use cases of unsupervised learning. Customer segmentation in marketing. Market basket analysis in retail. Anomaly detection in network security. Strengths of unsupervised learning does not require labeled data, useful for exploratory data analysis, can uncover hidden structures in data. Limitations of unsupervised learning difficult to evaluate the quality of results. It may produce ambiguous or less interpretable clusters, sensitive to parameter choices and data scaling. What is reinforcement learning? Reinforcement learning involves training agents through rewards and penalties. The agent learns to make sequential decisions to maximize cumulative reward. It is modeled as a Markov decision process. Use cases of reinforcement learning. Game playing such as AlphaGo, Mastering Go, robotics, robotics for autonomous navigation, personalized recommendations in online platforms. Strengths of reinforcement learning capable of learning complex behaviors through trial and error, adaptable to dynamic environments, effective for sequential design decision making tasks. Limitations of reinforcement learning it requires extensive exploration and training time, difficult to define an appropriate reward function, may not perform well in static or simple environments. Comparing supervised and unsupervised learning. So, supervised learning relies on labeled data while unsupervised does not. So, here we can see in the right side in that image, we can see in supervised it relies on labeled data whereas unsupervised is not, it is in unlabeled data. Supervised models tend to be more accurate for predictions tasks, whereas unsupervised learning excels in discovering data structures like finding patterns and clusters. So, coming to the comparing supervised and reinforcement learning. Supervised learning predicts fixed outputs, whereas reinforcement learns through interaction. So, coming to the second one, reinforcement is suitable for sequential decision problems, whereas supervised learning is more straightforward to implement with labeled data sets. Coming to the comparing unsupervised and reinforcement learning. Unsupervised learning explores data without feedback. Reinforcement learns through rewards. So here we can see unsupervised learning discovers patterns in data, whereas reinforcement learning learns through rewards. So coming to the second, it's clusters and groups data. Here it solves sequential tasks in reinforcement learning. Coming to the unsupervised learning, it understands data distribution, whereas in reinforcement learning, it adapts to change situations. So, hence, the unsupervised learning explores data without feedback and reinforcement learning learns with the rewards. Hence, reinforcement handles dynamic sequential tasks better and supervised is unsupervised is ideal for understanding data distribution and grouping. Practical use case mapping summary. Supervised learning is used in email filtering and credit scoring. Unsupervised learning is applied in customer segmentation and anomaly detection. Reinforcement learning is suited for robotics, gaming, and recommendation systems. Choosing the right paradigm. Consider data availability, labeled or unlabeled. Define task, prediction, pattern discovery, or decision making. Evaluate computational resources and desired outcomes. So here we can see, well, while choosing the right paradigm, firstly we have to consider the data availability, and secondly it must be labeled or unlabeled data. Coming to the second, we have to define the task based on prediction, pattern discovery, or decision making. Coming to the third one, we have to evaluate needs like computational resources and desired outcomes. Hence, the three key points come to the prediction, pattern discovery, or decision making. This evaluate the computational resources. Coming to the conclusion and future directions, all three paradigms have unique strengths and applications. Hybrid approaches are emerging to leverage multiple paradigms. Ongoing research aims to improve efficiency and effectiveness across all three types. Thank you.